Welcome to the deep dive. Today we're taking a close look at AI and healthcare data and really zeroing in on something that seems like it should be simple. Why is sharing healthcare data just so hard?
It feels counterintuitive, doesn't it?
Totally. So our mission for this deep dive is to unpack those difficulties, getting different systems to actually talk to each other smoothly. Especially now, with AI promising so much, we're digging into the sources you've shared with us.
Sounds good.
Now, you've probably heard terms like EHRs, electronic health records. Your doctor types notes into a computer instead of scribbling on a chart.
Right, the digitization step.
Exactly. Paper charts become digital files. That seems like a huge leap forward, yeah. All zeros and ones.
You'd think so?
So here's the puzzle. If it's all digital now, why is sharing that digital data still such a massive headache?
That really is the crux of the issue our sources get into. Even with EHRs, that digital data is, well, it's often trapped.
Trapped how?
They use the term silos, like grain silos on a farm, maybe. Separate containers.
Okay, silos. So data in one place doesn't easily get to another?
Precisely. Your information might be perfectly fine within, say, your hospital system.
Right.
Or the lab system, or a specialist you saw. But getting those systems to just share that data, that's the problem. They often don't communicate easily at all.
It's like different departments using totally different software that just won't work together.
That's a great analogy, yeah. They both have data, maybe even about the same thing, but they can't read each other's files easily.
Okay, so let's get a handle on this. Is this just like a few oddball systems causing trouble, or is it bigger?
Oh, it's definitely bigger. The sources are clear. This is a problem of scale. Globally, there are just tons of different EHR systems out there.
Right.
One source actually put a number on it. For the U.S., 1,000 different electronic health record systems. And they mention similar issues elsewhere.
1,000? Wow. Why so many?
Well, think about it. Each hospital, each clinic maybe wanted something tailored just for their specific needs.
Okay, custom builds.
Exactly. And when you customize, you might end up using slightly different words, different terminologies or different codes for the same condition or the same procedure.
So heart attack in one system might be myocardial infarction coded differently in another.
Precisely. And that kind of variation naturally leads to inconsistencies when you try to pull data together.
Yeah, I can see that.
And the real-world consequence. For you as a patient, or for the doctors and nurses, it often means someone has to manually type information from system A into system B.
You're kidding. Literally retyping.
Often, yes. Manual data entry, and that's not just slow.
It's asking for errors.
Hugely prone to errors, and it's a massive burden on healthcare staff who should be focused on care, not, data entry.
So this isn't just some back office IT frustration. It directly impacts patient care because you can't easily see the whole picture.
Absolutely. It makes getting a complete health history difficult.
And I imagine it slows down medical research, too, if you can't combine data sets easily.
Definitely. Research relies on large, clean data sets. This fragmentation hinders that. And of course, it adds costs to the whole system.
Which is why people started working on standards, right? To create a common language.
Exactly. That's the goal of healthcare data standards, to set rules so different systems can understand each other.
Like agreeing on vocabulary and grammar for data.
Pretty much. There's an organization called HL7 Health Level 7 that's been working on this for a long, long time. Decades, really.
Okay, HL7. Now, I keep hearing about FHIR lately. FHIR.
Yeah.
How does that fit in? Is it just like HL7 version 3.0 or something?
So FHIR, Fast Healthcare Interoperability Resources, is definitely part of the HL7 family, yes.
Yeah.
But it's more than just an update. It's really a different approach, a kind of evolution in how we think about modeling and exchanging healthcare data.
How so? What's different about it?
Well, think about the older HL7 standards like version 2.x. They were designed, way back. Pre-widespread internet, they tend to be more rigid, based on text messages being sent back and forth.
Right, clunkier maybe?
A bit, yeah. FHIR, on the other hand, was built from the ground up using modern web technologies, the kind of stuff that powers the internet apps we use every day.
Okay, so what does that mean practically? How does FHIR make things easier, at least on paper?
FHIR breaks data down into smaller, more manageable pieces called resources. Think like a patient resource or a medication resource or an observation for a lab result.
Little building blocks of information.
Exactly. Modular blocks. And it uses modern web standards and RESTful APIs. That's the tech behind countless websites and apps.
So developers are already familiar with this kind of approach.
Precisely. The aim was simplicity, making it much easier for developers to create apps that can pull out or send specific resources, just the piece of data they need.
Rather than wading through a huge, complex message.
Right. Its main focus is really on that clinical information patient data exchange, and adoption is growing fast, especially for newer projects needing interoperability.
Okay, so technically, FHIR sounds like a really smart way to tackle this data sharing mess. It seems built for the job.
From a technical design perspective, yes.
But I sense a but coming. Rolling this out across, you said, 1,000 systems in the U.S. alone, that sounds like the really tough part. Is implementing FHIR as easy in the real world?
And that's absolutely where the rubber meets the road. Our sources definitely highlight this. FHIR might be technically simpler, but getting any new standard adopted across the whole healthcare ecosystem, that's a massive challenge. It's complex, it's entrenched.
So implementation takes time and money.
Loads of time. And yes, it can be very costly. A huge issue is all the older systems, the legacy systems still running in many hospitals and clinics.
They weren't built for FHIR.
Exactly. They weren't built with these modern APIs in mind. So making them FHIR compatible takes real effort, sometimes workarounds.
And then there's the people side.
Absolutely. You've got to train doctors, nurses, IT staff, everyone on how to work with this new standard, these new workflows. That's a significant learning curve.
Right. It's the classic problem. Great tech idea hits the messy reality of existing infrastructure and human factors.
Couldn't have said it better.
This feels like a perfect place for AI to come in, though. If the systems can't easily talk, maybe AI can help translate. How does AI fit into bridging these gaps?
Yes, this is where AI starts to look like a really powerful tool in the toolkit. It can act as that translator and facilitator, as one source put it.
How does it do that?
Well, one key way is through AI-powered data mapping. Remember how we said different systems use different codes and terms?
Yeah, the heart attack versus myocardial infarction example.
Right. AI tools can learn these variations. They can automatically figure out how to translate data from System A's format into System B's format.
So instead of a person having to build a massive crosswalk table manually,
the AI can potentially learn and automate large parts of that mapping process, mapping diagnosis code XYZ to condition ABC automatically.
that sounds like it could save incredible amounts of time and reduce those manual errors we talked about.
Huge potential there, yes. And another big area is natural language processing, NLP.
Okay, understanding human language.
Exactly. Think about all the information locked away in doctor's notes, discharge summaries, the free text parts of the record.
Right. Not the neat drop-down menus, but the actual sentences.
Yes. NLP can read that unstructured text and pull out key pieces of information, diagnoses, symptoms, medications mentioned.
And turn it into structured data.
Turn it into structured data that other systems or other AI tools can actually understand and use for analysis.
Wow. So unlocking data that's currently really hard to use systematically.
Precisely. And AI can potentially help integrate data from even more sources, maybe beyond the main EHR, things like wearable devices, patient-reported outcomes, if the APIs are there to connect.
Okay, this is fascinating. Let's maybe zoom in on a specific example the sources mentioned. India. What makes achieving this data interoperability particularly tricky there? And how do solutions, including AI, need to adapt?
India is a really interesting case because the challenges are, well, they're significant and layered. You have the general problem of data silos we've discussed. But on top of that, there's often a real lack of standardized high-quality data to begin with. Data fragmentation is very widespread.
So the foundational data itself can be inconsistent.
Yes. And then you have infrastructure challenges. Things we might take for granted, like reliable, fast internet or powerful computing resources, aren't universally available everywhere.
Right. Connectivity can be patchy in some areas.
Definitely. And then there's the sheer diversity.
Culturally and linguistically, you mean?
Exactly. It's immense. You need healthcare systems that can potentially handle many different languages, and they need to be culturally sensitive in how they work.
That adds a whole other layer of complexity.
It really does. Plus, a huge factor, especially for widespread adoption, is cost effectiveness. Solutions need to be affordable to implement and maintain at scale.
So you can't just drop a standard Silicon Valley solution into that environment and expect it to work perfectly. It needs serious adaptation.
Absolutely. The solutions have to be pragmatic, tailored to the ground reality.
Like what kinds of adaptations are needed?
Well, it means investing in the basics, first things like data cleaning, getting better standardization.
Building a stronger foundation.
Right. It means leveraging existing infrastructure where possible, using cloud computing strategically, not necessarily demanding brand new expensive hardware everywhere.
Working with what's there.
And crucially, integrating with the systems already in use, the hospital information systems, the existing EHRs, using APIs as the glue to connect them.
Okay.
This is where national initiatives become really important. The sources mention India's Ayushman Bharat Digital Mission, the ABDM.
Right, I've heard of that.
It's aiming to create that unified digital health infrastructure, set standards, and make data more available across the board. It's a huge undertaking.
And addressing the language issue.
That requires specific development building AI models, for instance, that are trained on and understand multiple Indian languages, not just English. And designing systems that can actually function well, even if the internet connection isn't great, maybe using edge computing, where processing happens closer to the user, rather than relying solely on a distant cloud server.
It's a great example of needing context-specific solutions, not just one-size-fits-all tech.
Definitely. Technology has to serve the local reality.
Okay, through all of this discussion about sharing data more easily, there's the elephant in the room: privacy and security. That has to be absolutely critical.
Paramount. Non-negotiable.
But doesn't that naturally make sharing harder? How do you balance opening up data flow with locking it down for security?
It absolutely adds complexity. You have to comply with data privacy laws like the ones mentioned for India.
Right.
But there are techniques and technologies designed specifically for this balancing act. Things like anonymization, where you strip out direct identifiers, or pseudonymization, where you replace identifiers with codes.
So you can analyze trends without knowing who specifically.
Exactly. There's also differential privacy, which adds a bit of statistical noise to query results to protect individuals. And a really interesting approach mentioned is federated learning.
Federated learning, how does that work?
The idea there is you can train AI models on data that stays put, it remains distributed across different hospitals or systems. The model learns from the local data without that sensitive patient data ever having to be moved to a central location.
So the insights travel, but the raw, identifiable data doesn't need to be pulled together.
Exactly. It's a very promising technique for enhancing privacy while still enabling powerful AI development in healthcare.
Okay, so putting it all together, it sounds like a really tangled web technical hurdles, organizational inertia, specific environmental factors like in India.
It is definitely complex. Achieving truly seamless healthcare interoperability, it's arguably one of the biggest mountains healthcare systems worldwide are trying to climb right now.
Not a simple fix.
No quick fixes. It takes evolving the technical standards, like moving towards FHIR. It takes smartly applying AI tools for those translation and extraction tasks. And it needs careful, strategic rollout that understands the local context and puts privacy absolutely first.
But progress is being made by combining these things.
Yes, definitely. By advancing standards like FHIR, using AI as that bridge, and developing context-aware strategies like we discussed for India, we are moving towards a future where healthcare data can flow more effectively and securely.
And ultimately, this isn't just about making IT guys happier.
Not at all. It's fundamentally about enabling better, safer patient care, speeding up the medical research that finds new cures, and making the whole system work more efficiently for everyone.
So what does this all boil down to for you listening? We've seen that even though your health records might be digital, getting them to move smoothly between different doctors or hospitals, that interoperability piece is still a huge challenge.
Your data often gets stuck in those silos we mentioned.
Right. Which makes it tough for any one doctor to get your complete, up-to-date story easily. We talked about how standards like HL7 started the journey, and how the newer, web-savvy FHIR standard should make the technical side of sharing easier.
At least in theory.
In theory. But then reality hits. Rolling it out is complicated, expensive, and means dealing with lots of older systems that weren't built for it.
That implementation hurdle.
Exactly. And that's where AI is really stepping up, acting as a translator, using data mapping to connect different codes, using NLP to understand doctors' notes. basically helping bridge those gaps.
Turning unstructured into structured, mapping different languages.
Yeah, and we saw how in places like India, you have extra layers, fragmented data, patchy internet, many languages, affordability concerns, all shaping how solutions like the ABDM initiative need to work.
It has to fit the context?
Absolutely. And underlying all of it is the critical need for privacy, using techniques like anonymization or federated learning to protect your sensitive information.
Ultimately, solving this puzzle of secure, seamless data sharing, it's not just a tech problem, it's essential for you to get faster, safer care. It's vital for the research that develops new treatments. It makes the whole system run better.
Right.
And we're seeing that by combining modern standards like FHIR, the smarts of AI tools and strategies that respect local needs and privacy, we are genuinely making progress in breaking down those barriers.
So just think for a moment, what if? What if your healthcare data really could flow securely and instantly between every single place you receive care? Your GP, specialists, labs, hospitals.
Imagine the possibilities.
Right. What could that unlock for your own health, ensuring everyone treating you has the full picture? What about for medical research having vast connected data sets to find patterns and cures faster? Could it fundamentally change how healthcare is delivered in your community, making it more joined up, maybe more proactive?
It's about more than just bits and bytes talking.
Exactly. It's about breaking down those walls, those silos, to empower both you, the patient, and the people caring for you. It's about building a healthier future, really, one connected record at a time.